what do you want to? Is there anything that you want to study in particular?
15th chapter.
Which chapter? 15th.
Yeah.
Okay. All right. So what's the chapter's name? It's visualizing solid shapes, right?
Yeah.
Okay. So, can you tell me what is the difference between a sphere and a circle?
A square has like edges and vertex and face.
No, I'm not talking about a square. I'm talking about a sphere.
Oh.
Yeah, a sphere. What is the difference between them? Yes, Hiba? Okay. If I ask you, what shape is the earth? What is the shape of the earth?
Okay.
Sorry?
Circle.
Okay. So here is what we're going to see now. So you have done this chapter in your school, right, Hiba? Like in your school, they have done this, right?
Yeah.
So my question is, have you like what do you understand by solid shapes, and can you name any solid shapes, and why do we call them solid?
Three 3D shapes are called solid shapes.
Okay,
Solar
very
shapes.
good. Let me just write that down. Just gonna write that down. 3D shapes are called solid shapes. Okay. Yeah, right. Okay. So then is a circle a 3D shape?
No.
It's not. Then out of these two, which of them is a 3D shape?
I can't see the board. Can you write a little down?
Okay. Which of these two is a 3D shape? Okay. First of all, what do you understand by 3D? What does 3D mean?
Like solid shapes having length, height, and like length, height, and width.
Okay. Can you name any 3D shape around you? Just look around your room. Name anything that is 3D.
Square.
Square. Okay, let's see. So a square. So let's try to understand what is 3D and what is not 3D. Okay. So see, the thing is, let's just go to the basics.
Can I ask you a question?
Yeah, sure. Go ahead.
What is the difference between square, pyramid, and square?
Square, pyramid, and square. Okay, we'll come to that. We'll come to that a little later. First, let us differentiate between a sphere and a circle. Okay, that is like the basic um, distinction that we need to make. Okay, so yeah, we would want to talk about this. See, Hiba, what happens is there are different things. They're called dimensions. There are different things called dimensions. Okay, what I mean by that is when you say length, okay, when you say breadth, when you say height, these are all dimensions. Okay, these are how many dimensions? 1, 2, 3. So there are 3 dimensions. If something has all 3 of them, then we say it is a 3-dimensional figure. Okay, if it has only 2, then we say it is a 2-dimensional figure. Okay, like for example, if I ask you to measure, let's say, you can see the screen in front of you. Let's say I draw this. Just a minute. I draw this. What all can you measure in this? What all does this have? Let me just draw it again. Yeah, this rectangle, can you see it?
Yeah.
Yeah. So does it have a length?
Yeah.
Yes. Does it have a breadth? So wait a minute. This is its length. Just a minute. Okay. This is the length. Okay. Or let me just say the length is in this direction or this dimension. Does it have a breadth?
Yes.
Yes, it has a breadth. Does it have a height or depth? You can also call this depth. Okay. Does it have this, a height or depth?
Yeah.
No, it does not. So how many dimensions does this shape have?
Two.
2 dimensions, right? Yeah. So that's why we call it a 2-dimensional figure. It's a 2-dimensional figure and not a 3-dimensional figure because it has only 2 dimensions. Okay. Have you ever solved a Rubik's cube? I'm sorry, a Rubik's cube. Have you ever seen a Rubik's cube?
Yeah.
Yeah. Do you have one at your home?
No.
No, you don't.
No.
Okay. Do you have a lunchbox at your place in your house?
Yeah.
Do you have a lunchbox? Okay. Do me a favor, or okay, maybe not a lunchbox. It can be a
Yes.
pencil box. It can be a pencil box. It can be an eraser. Okay. So get me any such thing, a lunchbox, pencil box, or eraser. Just bring it and let me know when you're done.
I bought the lunchbox.
You got it? Okay. Take a look at the rectangle on the screen and take a look at your lunchbox. Do you find any differences in it? In these two things?
Yeah.
What are the differences?
It doesn't have any differences.
Sorry?
It doesn't have any difference.
There's no difference in its shape? It's the same?
Yeah.
Can this rectangle, let's say if this was instead of a screen, let's say it was a paper. Okay, imagine that the screen isn't a screen, it's a paper. And you were to cut out this rectangle and you place it on your table. Can this rectangle hold any food in it?
No.
No. But can the lunchbox hold any food in it?
Yeah. The
What
lunchbox has a depth and height.
Very good. It has a depth. Okay, so that is one difference that we find between them. That our lunchbox has this. Okay, and therefore the lunchbox becomes a three-dimensional figure, and we call that figure, actually we call it, what do we call that shape?
Square. Sorry, can you repeat the question again?
What do we call the shape of a lunchbox? Your lunchbox. Just take a look at your lunchbox and tell me what shape is it?
Square.
Is it square? Okay. Is it possible for you to switch on your camera and show me your lunchbox? If it's not okay, then it's totally fine. We can do something else. Uh, just a minute. I'm trying to open something for you. Okay. Um, Let me just share my screen again. Are you able to see my screen?
Yes.
Okay. I am going to make this. Okay. Just take a look. What shape does this look like? What will you call this shape? What shape is this? Hiba?
A rectangle.
Okay. Rectangle. Okay, it's a rectangle. I'm gonna keep it over here. Then okay. Now I'm just gonna draw one more thing. Okay. Just gonna zoom in a little bit. Are you able to see this?
Yes.
Okay. Does it look like a three-dimensional thing to you? Does it look like, you know, a Rubik's Cube? Does it look like something that can hold something in it?
Yes.
Yeah. Okay. Whereas take a look at this. Does this look like something that can hold some material in it? This one, the
No.
rectangle? No,
It
right?
is a two-dimensional shape.
Sorry.
It is a two-dimensional shape.
Yes, it is two-dimensional. This is called a rectangle, or if you want, I'm just gonna go draw. I'm just gonna go draw a cube. Sorry, a square. Oops. I'm sorry. Okay, so this is a square, and this, on the other hand, is a cube. Do you see the difference between them?
Can you show me the square again?
Yeah, this is the square, or you know what? I'm just gonna do this. Just gonna bring it over here.
Yes, there's a difference.
Yeah. So what is the difference?
The square is a two-dimensional shape, and the
Okay.
cube is a three-dimensional shape.
Very good. Now I'm just going to do one thing. Okay, so if you look at this square like this, or this cube, if you look at it from this angle, okay, let's imagine that this cube is a building and you're standing right in front of it. You're standing right in front of a building, and it looks to you like this. Does it look like a square to you?
Yes.
Yeah, it looks like a square. But so if you just look at it from this angle, if you look at it from the front, it looks like a two-dimensional shape. Why is it looking like a two-dimensional shape, whereas it is a three-dimensional shape?
Because when we look from the front, it looks like a square, and square is a two-dimensional shape.
Okay, but why is it looking like a square, or why is it looking like, how come we are not able to see the third dimension? We are able to see two dimensions, right? We're able to see this, if you can see my cursor, we're able to see the horizontal dimension, we're able to see the vertical dimension, but we're not able to see the third dimension, which was this thing, the front versus back dimension. We're not able to see that. So tell me why?
Because you are standing in the front.
Yeah, we're standing in the front of it, and the third dimension, it has, it has gotten hidden, it has become hidden. What happens is that if you take a look at it, just a minute. Wait. I'm just going to draw something. Um, 1 minute.
Yes.
Okay. Uh, hmm, point. Let's see. Okay, this is not showing it the way I want to show it, but never mind. Okay, never mind. So let's come back to where we started. We were talking about how this is a three-dimensional shape and that is two-dimensional. Okay, so and we were also talking about why this looks like a square from the front, because it is made up of, can you count how many squares, how many square faces it has? Like the last time we saw one face, right? Now can you count how many square faces it has?
Yeah.
And if you want me to make it stop moving, I'll, yeah.
6.
Yeah, it has 6. So basically there are 6 squares. Okay, there are 6 squares and you arrange them in such a way that you get a three-dimensional figure. Okay, so basically what you're doing is you're taking one square. Okay, this is one square. Let's just get it colored. Okay, then there's another square, the third square. Okay, just a minute, hold on. Yes, Eba, I'm sorry about that. Yeah, so yeah, now go ahead and calculate, or sorry, go ahead and count the number of squares that you can see. As you said that 6, right? So can you see the way that the 6 squares are arranged?
Yes.
Yeah, so they are basically arranged like this. Sorry. Okay, so you have one square. Okay, and you have another square which you are arranging, like you are making it stand on top of the first square. Okay, so like that you make all of the 6 squares stand next to each other, and that's how it makes a cube. Now let's talk about uh, again, let's come back to what we were talking about the first time. We were talking about sphere versus circle. Okay, um let me ask you the same question. Okay, wait, before we go to that, first tell me your lunchbox again. What shape is it called?
A square.
Your lunchbox.
Square.
Square. Okay. First tell me the square on the right that you can see, this one. What is this shape called?
Square.
And what is this called on the left? Is this also square or something else?
Square pyramid.
Okay, but what like what term do you use for this? Have you ever seen this term in uh like in your real life? Have you ever seen this shape in your real life?
Yes. Cube.
Yeah. Yes, it's called a cube. Okay. So if I were to change this and if I were to draw a rectangle over here, wait, no. Okay, I'm gonna draw a rectangle. Okay. So this is a rectangle, and let's say I um draw another shape over here. I'm going to just a minute. I will draw another 3D shape over there, and you have to tell me okay, why is this not just a minute. Okay, got it. Okay, can you see this image on the left?
The screen is loading.
Okay. It's still loading.
Yeah, I will rejoin.
Wait, I will just stop sharing and then I'll reshare it. Wait. Can you see it now? Hiba?
No.
No, you can't. Okay. Hmm. I'm sorry about the technical glitches.
It's okay.
Okay. Now tell me if you're able to see it. Okay. What about now? Can you see it now?
It's still loading.
Okay. I don't know what I can do. Wait a sec. Let me just try sharing my whiteboard itself. Are you able to see the whiteboard?
Did you share it right now?
I'm saying, are you able to see the whiteboard?
Yeah, but you didn't share the whiteboard.
Okay. I'm sharing the whiteboard only.
The screen is still loading.
Okay, it's still loading. Oh my god, that's really problematic. Listen, I will just let's both do one thing. Or wait, you join, you leave and then join. Okay.
Okay.
Hiba, can you see?
I can see now.
You can see it now. Okay.
Yeah.
Um. hmm. All right. Finally. So you can see just the whiteboard, right? You can't see anything else.
No. I can only
Okay.
see the whiteboard.
Now.
Yeah, I can see now.
Okay. So see this. Right. Okay. So are you able to see this shape that they're showing?
Yeah.
That shape, it's actually called a cuboid. Okay, both the shapes, like this one also on the right window and on the left window, both of them, they're called cuboids. Okay, and I was basically just comparing them with the where did my rectangle go now. Okay, so I was comparing them with this rectangle. Can you just look at the rectangle on the right hand side? Okay, this one. Can you see the difference between, can you tell me the difference between the rectangle and the
Keyboard.
cuboid? Can you hear me?
Yeah.
Yeah. So I was saying, can you tell me the difference between the two, the rectangle and the cuboid?
The cuboid is a three-dimensional shape,
Hmm.
and the rectangle is a two-dimensional shape.
Yeah. Okay. So now you know which shape we call what, right? Which shape is a cube, which shape is a cuboid. Actually, so in the next class, what I'm going to do is, since we were not going to complete this, we were not going to start this chapter today. Like I was planning on starting, I was planning on continuing chance and probability. So, anyways, in the next class, we're going to see some proper, examples of this. Okay. Well, now take a look around you and name something that you can see which is cuboid in shape. Hmm. Name something that is cuboid in shape. Yes, Hiba, take a look around you.
It's a box.
A box. Which box is it? What do you use it for?
It is like some part of a machine. Like in it, there's some part of the machine.
Okay, very good. All right. Anything else? Are you sitting in your bedroom or are you sitting in the drawing room?
In my bedroom.
What shape is your bedroom?
A cuboid.
Very good. It is a cuboid. And the lunchbox that you got, what shape was that?
Square.
Again, it was a square. Can you put food inside a square? Take a look at the square right in front of you on the screen.
No, it was a cuboid.
It was a cuboid, right? Okay. So it was a cuboid. Which color was your lunchbox?
White.
Okay. Anything else that you can see that's cuboid around you?
A mask box.
Matchbox. Very good. Very good. Anything else?
No.
No. Take a look at your. Now do one thing. Do you have your maths textbook in front of you?
Yeah.
Yeah. Close your textbook. Keep it in front of you. Okay. Like for example, I have one textbook over here. Okay. Take a textbook. You can see it. Okay. This is a textbook. It's coming blurred in my video. Anyway, so this is the textbook. Keep it like that in front of you. So keep it like that in front of you. What shape is this textbook? Your textbook. Take a look at your textbook.
A rectangle.
Is it rectangle or does? Okay, fine. Just see how
cuboid.
many.
Your voice is not coming. I will rejoin.
Hello, can you hear me, Hiba? Hello. Hiba, are you able to hear me? Hiba, are you able to hear me? Hiba, can you hear me? You can hear me? Okay.
Yeah.
Yeah. So now let's say this is my textbook. Okay. What are the 3 dimensions that you said it's a cuboid, and a cuboid, as we know, is a 3-dimensional figure. So can you tell me what are the 3 dimensions in this? Take a look at it and
The height.
Okay, and what is the height? This thing? Is this
Yeah.
the height? Okay, this is the height. All right. Then
And the length.
the length of it. Okay, the length of it. This one.
Yeah.
The length of the textbook. Then
And the breadth.
the breadth, which is this one, right?
Yeah.
Yeah. So there are 3. So we have the length, the breadth,
and the height.
and the height. Okay. So the thing is, you have to rotate it a little bit to see the height. If you just see it like this, it looks like a rectangle, right? If you just see it like this, but it's actually not, because there's a There's a dimension that we are missing. We should rotate it and see. So there's 1, 2, and then when we rotate it, we see the third dimension. Okay. So it is a 3-dimensional figure. Now, Hiba, open your book, take out any page. Okay. Oops. I'm sorry. So take out any page from your book.
I took.
What shape is the page? If you just flatly lay it, what shape is the page?
A single page.
Yeah, one single page. What is the shape of it?
Square.
Is it square?
Sorry, rectangle.
It is a rectangle. And what dimension is the page?
2-dimensional.
It is 2-dimensional. Now, how is it possible that the textbook is a cuboid, but each single page is a rectangle?
Because the paper is thin and the textbook is thick.
Yes. So that is what is happening. That the paper, it doesn't have the dimension of height. Okay. So what is happening is each of these sheets, okay, they don't have the dimension of height. We are giving the book the dimension of height. How are we giving it? By stacking each of the papers on top of each other. So that is how the book is getting its height. The book is getting its height by us stacking so many pages together. Okay, so the dimensions of the book, the length and breadth, are going to be the same as the length and breadth of each sheet of paper, right? Length and breadth. But the height will depend on the number of pages. Isn't that right, Eva?
Yeah.
Yeah. So one more thing is that, okay, so we can say that this book, okay, let's say this book is a cuboid, right? So this book is a cuboid. Imagine any cuboid, like this cuboid on the left of the screen. Okay. If you were to slice it, if you were to take out, like if you were to slice it multiple times and take out one tiny slice, okay, like one very thin slice of it, of this cuboid, okay, just like slice it through, take a sharp knife and slice it through, take that very thin slice. What will the shape of that slice be?
Rectangle.
Yes, exactly, be a rectangle. And how do we know that? Because we know it through our what we have just observed in our book. Okay, this is a book, and let's say we have sliced the book into many parts, and each slice is a page, each slice is a sheet. So that sheet is the shape of a rectangle. Now can you imagine, okay, imagine a football. Okay, not a football, something that's solid. Okay, take something like an orange. Okay, take an orange. What is the shape of an orange?
Sphere.
Very good. There's a sphere. Have you ever seen, slices of oranges? Okay, not orange. If you want, you can take a lemon also. Okay, just slice it through and take a very thin slice of that lemon, and you put it on your.
It will become a circle.
Very good. It will be a circle. Okay, and you put that circle on your drink, and you drink it nicely like a cocktail or something. Oh, sorry, a mocktail. Okay.
Yeah.
So the lemon was a sphere, but when you slice through it, what do you get?
Circle.
Circle. Achha, tell me one thing. So the lemon, okay, there's a lemon. Let me just show you a lemon. Wait. Oops, where did how much time do we have? You can see my screen, right?
Yeah.
Okay, so let's say this doesn't look like a sphere. Let's take an orange. Okay. So I have this orange in front of me. I think this one is a better orange. Yeah, I have this orange in front of me. take a look at this part of the orange. Can you see where I'm pointing my cursor?
Yeah.
Okay. So take a look at this part. If you slice the orange from the top part, okay, versus when you slice it right from the middle, will there be a difference in the slices, the size of the slices?
Yeah.
Which one will be the biggest slice of the orange?
If we cut it from the center.
Yes, right from the middle of it. When you slice it, then you will get the largest circle, the largest slice. Okay. So can you now tell me that if you were, so now we just now saw how a book is made, right? A book is made by, or in other words, how is a cuboid made? When you stack a lot of rectangles on top of each other. Okay, you take same size rectangles, again hear me carefully, same size rectangles, and you stack them all on top of each other. What do you get?
Cuboid.
A cuboid. So how, in the same manner, just explain to me, how will you get a sphere? Yes, Eba?
If we have like pieces of circle and we stack them together,
Yeah,
we will get
we'll get a sphere. Okay. So the thing is, we'll come to the point of a sphere a little later. Okay, we'll probably come to it in the next class because we don't have enough time. But in short, I can say this, that in a sphere, what you can do is, you have the slices, they're going to be of different sizes. Okay, but the size is not going to be random. The sizes are going to be
it
such
has
that,
to be from
yeah,
small to bigger.
yeah, smaller to bigger, and then again bigger to smaller, right?
Yeah.
So then you will get a sphere. Now, can you think about, have you seen a cylinder? Do you know what is a cylinder?
Yeah.
A cylindrical shape. Can you
Yeah.
name anything that is cylindrical around you or in your house?
The cylinder, like
Gas
the
cylinder,
gas.
yes. Anything else?
No. A perfume bottle.
Okay, take a look at this. What shape is this?
Cylinder.
Yes, it is a cylinder. Have you ever drunk coffee or like Coke or something from a can?
Yeah.
What shape is that can?
Cylinder.
Cylinder. Now tell me, just have a cylinder in your mind. Okay, one second. Okay, so you have this cylinder in front of you. I think this one would be a better example. Yeah. Oops. Okay, so you can see these green cylinders, right? Hiba, now tell me, how will you obtain a cylinder in the same manner that we obtained a cuboid and a sphere? Okay, before we get to that, when you slice through a cylinder, what will you get?
Circle.
Very good, a circle. And what is the difference between a sphere and a cylinder then? The slice of a cylinder also is a circle,
Yeah,
and
I
of a
think
sphere also is a circle.
in the sphere, when we are like we have to get a circle of different sizes from small to big and then from big to small. In cylinder, we can just get one size of
Yes,
the circle.
right. So if you take a lot of coins of the same size, okay, and you just stack them on top of each other, which shape will you get?
Cylinder.
A cylinder, right? Okay, so we will leave it till here. Okay, I have to go play. I'm really sorry that I'm ending the class 3 minutes early.